Hello developers, let's start developing. It's the night of December 2020, 2022. Sorry, sometimes I still think it's March 2020, but that's not an issue. Anyway, the ninth task of this year's Advent of Code is open and we can take a look at it. I haven't seen it, so we'll need to see what is going on. And as always, we will try to solve it the best we can. So we have a row bridge. Else I'm able to make it through, but you are not really. Rope physics. Okay. What? Consider a rope at a knot at each end. Mark the head and tail of the rope. Head moves. Uh-huh. Okay, something is moving along something. Hypothetical series of motion, I don't know how the tail would move. Okay, we might have some rules. We have two dots, special dots on a matrix, and they are moving in some according to some rules, and we need to find out where they are, something like. If the head is ever two steps directly up, down, left, or right from the tail must also move one step in that direction so that it remains close enough. Okay, so if they're in the same column or row, they're using that column or row. Otherwise, one step diagonally to keep up. So if the head goes diagonally, the tail goes diagonally. Okay. Or if the head goes away, the tail goes diagonally. Initial state. So on the initial state, they are all in the same point. And S is the start. So R4. The head goes right 4 steps. Aha. Aha. It says it's right 4 steps is not to go directly right 4 steps, but go right once and once and once and once. Okay. Okay. You can count up all of the positions that you visited at least once. I don't really get the task, but on the other hand, I think that a straight up simulation will solve it, which means that if we get these motions, then it's okay. Let's try it. So our input is this. And it will be quite easy to parse. We can do a simple regex, or we don't actually even need a regex for this. Yeah, I like regexes, so I will try it. So that's begin, and then we have an R or a U or an L or a D. Since there are only four possibilities, I will be explicit. Then we have a space, and then we have some numbers. Because remember, this time we're not limited. This could be 111 if we want. And let's take a look at the bigger input, because I want to do something that might be input aware, so to say, like when we did. So it's 1 2 1 2 1 2 3 4 1 2 3 4 1 2 3 4, something like that. A lot of things. I'll actually run some code. I think it would. So where is our thing? Let's see. We have 2000 lines, and let's parse the input first. Read input lines for the day, and once we have the lines, we'll just need to match them. Not listeners, lines. Come on. Not that. Either that will work as well. But line dot match this thing. I'll just put this here. So match this regex. Oh, this was the problem why it was yelling at me. So we have the match, and this will match the first and the last parameter. Yes, R4, D111. So we can just say for the matching, return something that will have a direction, that will be the first match, and it will have a distance, which will be a number for the second match. And then we can return this, and we have that our is direction, that is a string, distance, that is a number, direction is not actually a string, is one of RULD. And then our input is not a string, but it's an input array. Is that how I declared it? Yeah. So everybody is happy except that the input doesn't says that it's not happy. Yeah, because it cannot verify that this is actually a direction. This is a direction, and here I will say to the compiler, don't worry, this is a direction. This will be a direction, and I swear I'm not lying. Now, let's run the test loop for a while, and since we have our input, we can what can we do? We can group them basically. I have a method called group reduce, and I want something like this. But I think it got the signatures all wrong. So what is an A in this scenario? A is input and B is a number. So yeah, the first one says how we want to group, on what key we want to group them by, and the second one is how we want to reduce them. And then we need another parameter that will be an empty array, empty object. This will basically run a grouping and a reducing operation at the same time. It will run a group, and then on that group it will run a reduce function. And in this case, what we want to do, this is an accumulator, this is an item, standard reduce signature, and let's call this an item as well, so that we have, so we will need to, for each item, just return the accumulator plus item.distance. Yeah, it's much simpler than we wanted to, and we can just console log this. This is not great code, but it will give us some analysis of the data that I want to make sure. What is the bounding rectangle, so to say? So what happens if we go up all the time? We will go 3000 levels, characters up. If we go down all the time, if we go left, if we go right, which means that if I put the starting point at a index of 3000, 3000, it will never go into the negative numbers. So this way I can only work with positive numbers, which are, to be honest, better. So I will define something like this. And then we will be going from the center. This way avoids having negative numbers. We can do a bit of optimization on this to dynamically calculate it, but it works either way. If we had lots of inputs that we would have to manage, then I would have this as a dynamic to basically calculate it on the specific input data. But for my case, we're gonna go with 1000. So now we have our inputs. So we need to set up some things like this. Let's have a visited array that will have all the places that our tail has visited. That's what we were looking for, right? And this will be a record that will have a number and that will have a array of numbers, for example. No, a set of numbers. Yeah, so I will keep my visited things in such a, actually this could be no, it's a request, in such a structure that we will have the row number as an index, and then for the columns that are actually visited on that row number, we will have a set of numbers, which means this will be make it so that if we visit the same location twice, we will just add it to the set and set will have, okay, I'm good, I already have one. So we have the visiteds where we will keep our result, and we will need the current position. And I will have two. variables. Actually, I will have 4 variables. Head x, head y. Yeah, this gets worse in multiple dimensions, but fortunately we only have 2 dimensions, so that's 4 variables. Tail x, that's starting at center x. Tail y, that's starting at center y. So now we can just say for of actually. And let's be fancy and deconstruct this immediately. So we will need to have a direction and a distance. And this is the kind of stupid part because we will have to simulate this a few times. So this is for a regular for index from 0 less than distance. We're gonna move the head, something like this. We're gonna have, because if we are for U4 is basically the same as R, U. So each of these is an independent thing. So we will be simulating them independently, so to say. And how does the simulation go? If we're going right, increase the head X, up, increase the head Y, okay. Increase the head X, decrease the head Y. Yes, that is the correct. So after this switch, we have changed the position, correctly changed the position of the head. And now we need to update. This doesn't make sense. It is what we need, but for the tail, not the head. So after we've done this, we need to move the tail. Let's have it as a comment so we know what we were doing. And I would definitely move this to a separate method. So we are moving the tail. And now the direction is not really important. What is important is the relative positions of heads and the tails. So if, let's do some if. What are the situations? And I'm gonna be agnostic about which way the head moved. I'm not gonna say if the head moved up, then most likely the tail will move up and things like that. But I will just implement the rules. That means that we have a case when we need to locate the head compared to the tail. So we can have basically different moves on the head, on the X and the Y. We can separate the move on the head and on the X and the Y, and I think this will work. So we can manage the horizontal first. And on the horizontal, we can have 3 cases. If head, that's the X, is bigger than the tail X, this is it. If the tail is in some X direction, then we're moving for a one step, trying to get closer to the tail in the correct direction. And for the vertical, it will be just the same. If the head is off in some direction, move in that direction. That's all there is. And now we need to basically do the marking. But we're not doing the markings on the head, we're making the markings on the tail. tail x dot add tail y. And after all the moving and whatnot is done, actually I'm gonna do something like this. Get all the keys. Entries is just as efficient, but keys are much better to think about. Map each key to a visited key, map each key to the specific set, and then sum over the size. Basically, if we have, in this case, what we will have? We will have this element inside the visited, and that element will be a set of two numbers, and then a set of two numbers, and then a set of four numbers, then a set of one number, then a set of four numbers. And we say for each of the sets, get their numbers and sum them up and return this. And it says that the result is 20 and we needed 13. Do I have everything? So yeah, most likely we have a bug. Let's see what we got. So now I'm gonna debug starting from the top down. So let's see the result that we got. Does it look anything like what we were supposed to get? We have a set of 1 and 4 and 4 and 5 and 2. And we have 2, 2, 4, 1, 4. This is not what we were supposed to get. And on the other hand, the summing up works quite nicely because we have 12, 17, 19, 20. So at least we know that this line is correct. Okay, now let's debug. First of all, let's see if our input is correct. We have 8 and the last one is R2, and here we have 8 and the last one is R2. So, yeah, what is the direction R? What is the distance for? Are we using the distance in the if in the inner for loop? We shouldn't, and we're not. So what is the head X? Let's add it here. Add X, add Y, tail X, tail Y. At the start, the head. I managed to do something wrong. Yes, it's this case. Because I'm moving the head, the tail all the time. So this means that in which direction I'm moving the head, the tail just overlaps it. And we have something that might not be. Yeah, this is the that if it's close enough, if it's touching, it doesn't need to move. The tail only moves if it has to move. Yeah, so in this case, the head moves and the tail says, I'm fine. And in this case, the head moves and it comes here and the tail has, oh, I have to play catch up. Yeah, let's remove this breakpoint. We have a situation that we haven't covered. Move the tail. And here we have something called should we move. Should we move horizontally? I said I'm gonna be separating the two movements because they are kinda independent. So that means if not this, if this is bigger than 1, then and only then you need to move. Yeah, this can be done simpler, but I don't particularly like nested ifs, but for the time being, I think they might do. So this means if you, horizontally you are more than one step away, do it. Move. If vertically you are more than one step away, do it. Otherwise, you're golden. Let's see what happens now. And now we undershot our objective because we have set of 1, 2, 2, 4, 1. And we needed, this is the 2 to 4 part, definitely. But we don't have something that we wanted to do. And in this case, I'm gonna put this at 0, 0, so it might be easier to reason about. Yeah, so we have 0, 0. Yep, that is okay, but we don't have these three. We have 1, 0 and 1, 3. No, no, we're simulating something wrong. Let's take a look at it. If nothing helps, we will have to basically write some code that will generate this. So, headway, everything is at 0, 0. We are at 1, 0. That means that our tail had got here. If I'm correct, the tail should say, I'm fine. Yep. And the visited is empty. We will define at the 0, 0 position, which is correct. Okay. And now we need to go once more. 2, 0. Yep. And this is gonna say, yeah, I need to catch up. I need to catch up. And this will say, I'm good. So the tail is at 1, 0. And then the 1 will also get a 0. Oh, we have something inverted. We're counting it this way. So let's start up Excel. Excel kind of froze, so we'll get back to this, but we need 1 and then 2 and then 1, 2, 3 and then 1, 2, 3, 4 and then 1, 2, 3. Let's run this over and see what actual results were. For the first few steps, it seemed that we were doing good. You know what? Let's invert this because it doesn't really matter how we're doing it. And this should look similar to what we are given in the task. For the zeros, we have 0, 1, 2, 3. For the ones, do we have just a 4? No. For the twos, we have just a 3. And for the threes, we have 3, 2, 4, 1. And we didn't move. No, this is moving totally in a different direction. The problem is somewhere around here when we're going up a bit. Let's debug that. So now we have our first input. Let's just take this and see what the visitors are now. Oh, messed up the debug. So now we have direction and distance R4. This is our first thing. Let's see what happens after that thing is done. Now we have U4. That's the second part. Let's see what our visitors look like. We visited 2, 1, 2, 3, 4. 0, 1, 2, 3. And that is correct because we visited basically this part. And now the next step that we need to go is here. Both one up by X and by Y. Because head is on 4, 0, tail is on 3, 0. So if we are correct, head should be on 4, 1. Yes. And now head is on 4, 1. Let's see once more what happens. Oh, if the right now the tail should not move because it's touching. Doesn't move, doesn't move. Okay. The visitors are not changed because we didn't move anything. So now we're gonna have to be 4, 2. And now oh, we simulated it wrongly. It's not independent. It's not independent. To be honest, my way of moving the tail is better. But it's not the one that's given in the... So instead, when the head moves here and the tail is here, the goal is basically to get the tail to touch. And I moved it here. So I didn't move it one up, one across. I just say, well, it's enough if I move it one up. And so my tail will not go to 4, 1 as it goes here, it will go to 3, 1. And you can see it here. Yeah, it went to 3, 1. Okay, we have some more code to write. What is this case? This might not be correct. Let's remove it. We can always undo it. So, how do we want to move the tail? Go away, Mr. Breakpoint. Yeah, let's not be smart and let's implement it as it was given. So, touching the head, no movie. It's touching it if we have the tail X and it's in some position here. If the maximum difference between their X and Y coordinate is exactly 1, they are touching. Because then that means that the head is somewhere in the 3 by 3 block over there. So we just need to say if mat.abs headaches minus tails and headaches minus tails. So those are two different conditions. I won't do any maths. If this is less than or equal to 1, and if this is less than or equal to 1, don't do anything. Because don't move the tail. And if we're not moving the tail, it's quite impossible to get to a new position by not moving. Otherwise, now we need to do whether we have a horizontal or a vertical move. If head tails equals to tail x, then we do this. Yeah, we move along the y-axis. And now we already know that we need to move. We move along the y-axis. And this is gonna be one huge convoluted mess. So right now, we know when we are here, since this already failed, this check failed, this means that the head is at least 2 spaces away from the tail. And we have 3 distinct possibilities. It's moved horizontally, and that's this case, and it's moved vertically, that's this case, or it moved diagonally somewhere. And then we basically need to do both of these. And this might work, but it's one of the worst codes I've ever written. So I will try to re-reason it about. Of course, assuming that it works. And it gave me 12 and I was looking for 13. Meh. didn't count the 0, 0 because we said we cannot get to somewhere when we're not moving, but we are actually need to add. So in the initial state, I added the 0, 0 set. Even if it's not 0, 0, it's the center, x center, y. Let's see. Huh. Yeah, we got the solution, but I think that with all this talk, this might be equivalent to this. It's not. Now, actually, what we want to do. Yeah, I think this will work. Of course, this will work. We're just restating the obvious. But right now, this will work even if, I think so, even if we omit that part, because it's logically the same. I think. Looks like we are correct. Because this means, let's go over it again. This is not the best code, but it could be more understandable. So, if we got here, that means that the head is detached and we need to get close to it. So, basically, now we can count it as an independent movement, because if the head is detached, there could be few cases, but it boils down that we should move toward the head both on the x and on the y, and we are actually moving even if we're on the same x, but we're moving exactly 0, so to say. So because I have the situations when the head is forward on the y, go to the y, when the head is backward on the y, go to the y, and when its head is exactly there, well, then you don't move. But at the very least, one of these conditions will be correct, so to say. I might have made an error somewhere, because spatial reasoning is hard. And it seems I have some intermittent internet issues. But let's see what happens now. I will get some number. Might not have, yeah. This is what I wanted to avoid with the negative numbers, because it's a bit harder to think. But let's see if this thing is correct. That's the right answer. We are one gold star closer. The good thing about advent of code that doesn't happen in the real life is that they take specific care that this thing here has basically all the use cases that thought of. So this is a perfect thing, and it's quite likely that if it works on your input, it's gonna work on the huge problem. And if it's you get something like that it works on the small input but it doesn't work on the actual input, then you need to basically reread the specification because something is off. Anyway, we're done with the first half. Let's take on the second one. A rope snaps. Oops. Some of the ropes are broken, now whipping to values fell through the air. Moving too quickly to grab. You only have a few seconds to choose how to arch your body to avoid being hit. Support longer ropes. Rope consisting of 10 knots. One knot is still the head of the rope and was considered motion down the rope. Follow the knock in front and using some rules above. Oh. Oh. And we want to see the positions when the new trail visits. This might be bad. Okay? Is the same, exact same task. I'm gonna keep on using the negative value, so the center thing doesn't really matter then. And I can just be kind of explicit, says 0 is a new set of 0. Zero. What's the problem? Oh, array of 0. Specify here. This is 0, this is 0, this is 0. Now, first of all, I'll try to I don't need this console log. Go back to the small input. Yeah, I'll stop the debugging here for the moment. We can always start it here. So if this is our input, let's resolve part 1 and the part 2 implementation. Yeah, this will of course give us again a 20. A 13, not a 20. Sorry. But let's make an implementation right now that will have a variable number of nodes, and that variable number of nodes is 2. That will be something like this. that means that we could extract this into a method. And it says, I don't know how. Well, I'm gonna help you. Come on. No, it's not gonna guess. Yep, that's exactly what I wanted. Is it the same exactly what I wanted? Yeah, return. And this is an evil mutable method. Because this actually, the end result of this method will be that it will change the tail parameter. So this is an unpure function because if we call it twice with the same data, we will have a problem. So in this case, we can just say that the head is the first knot, and then we can modify the first knot. Just a second. So now this index is where? How do you mean this code is unreachable? It's definitely reachable. It seems that yeah, we have a return. It triggers treat something as a return. So now we just gonna loop. Yeah, it's not gonna be index. This is gonna be index or something like that, not index. And we're gonna start at 1. And actually, we don't need to follow the head. Each node follows the node in front of it. So we're saying not index follow nodes not of index -1. Yeah. So this node is supposed to follow this node for each of them. And in our case, when we only have 2 nodes, well, the second one follows the first. And then, of course, the tail is the last one. Tail y, tail y, tail y, tail x. Seems that we have some kind of a solution. Let's see if we have 3, 4, 5, 6, 7, 8, 9, 10. Let's see. 1, 2, 0, 1, 2, 3, 4, 6. Once more. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, we're fine. 3, 4, 5, 6, 7, 8, 9. If everything goes well, this should return 1. because the thing it didn't move at all. This is the case, where are you? Yeah, this is the first case when we basically are wiggling the left and right, and the 9 stays at the same spot. Let's see with the bigger example, the larger example. When the 9 passes through how many? 36 positions. We're gonna have to restart the processing. It says 36. So it's quite possible that we actually have some solution here, because we maybe overanalyzed the first part, but in this case we got lucky, and that gave us uh, the ability to basically modify it easily and have the second part, because we developed a general way of how one node follows another, one node follows another around. And then we just said, well, now we have 10 nodes that are each following each other, and we just string them up, and it seems to be working. Once again, it's working when Advent of Code says it's working. It says that it's gonna visit 2,566 places, and let's see what the Advent of Code says about that. And that's the right answer. Fortunately, this was a relatively hard thing to interpret, as the input was trivial, but the task required a lot of visualization and things like that. Fortunately, we managed to do it. That's a great thing. I'm quite happy right now, especially that all the hard work that we did and all the analysis in the first part definitely paid off for the second part, where we just use some minimal changes to our code. I'm even tempted to move this method back inside, because I really don't like even mutable methods that don't return a result, just change their parameters. I will think about how to make this maybe a little cleaner or better, or something like that, but no promises, because on the other hand, we do have a task that we need to get back to. If you remember, we still haven't done task number 7, because somebody needed to be out with friends drinking beer, and that's part of life. That is also an extremely important one. Anyway, uh, that was the solution to task number 9. Talk to you tomorrow when we're going to be solving task number 10. Bye.